Well, hello folks, and welcome to episode 172 of Retro Power Uncut. And here we are in the mouth of our Media Blast room, where Sam has been working on Allegro project number 2, Project Silk, I think it may be called actually, having seen the name on our little project coordination software, on the Global Workshop software. And yeah, Sam's been working on that in here because the fume extraction is obviously very good in here because we have a huge extractor for when we're shot blasting in here, and he was generating quite a bit of smoke and mess from cleaning out the seam sealer from some of the seams. These cars have a lot of weld-through seam sealer in, and we needed to remove it to do the seam brazing, which is what's been going on in here. So yeah, that's why it's in a slightly strange location. But yeah, Sam's been working on this and done a very nice job of the seam brazing, and that is now all done. And looking really good. You can see the various bits around the engine bays and all of the vast bulk of the seams on the underside. He's also finished off welding up any of the holes and little bits and details underneath that needed finishing off, and got all that complete and got it back on a trolley now, ready to get back out into the workshop, because one of the next tasks on this car will be swapping the running gear from the first of the 2 Allegros, which we'll see shortly, into this one for a dry build on this, just to make sure we haven't missed anything, and also that we're going to need the running gear in for doing the wheel clearance checks and just doing all the final checks when we fit the body panels. Which, talking of the body panels are underway at KS Composites. I believe they're making the moulds for those this week. I'm led to believe possibly tomorrow the bulk of the moulds are being taken. From both the books that we've made in MDF and from the doors, the actual OEM doors on this car, they're being used to take the moulds from, and the original bonnet and boot lids. So yeah, the moulds, sorry, actually no, not the bonnet and boot lids, but the doors, the moulds have been taken from the doors. So yeah, that's, I believe, happening tomorrow, as long as schedules haven't sort of slipped anymore. So yeah, it shouldn't be too long, you know, a couple of weeks or so, and we should be seeing the final carbon parts. Interestingly, while I'm here and while I'm talking about seam brazing, I saw a comment amongst our many comments on YouTube. I try to read some of them. I don't manage to read all of them. Years ago, I'd have been able to read them all. With 2 very young children now, I struggle for any time at any point in the day to actually watch videos. But I've seen some of the comments, and one of them was regarding intergranular cracking surrounding braze on mild steel. And the particular, I can't remember who made the comment, but whoever did will know who they are. And they raised a point about brazing, but they were referring to gas brazing using an oxyacetylene or oxypropane torch. Very different process to this. With the gas process, it's very hard to not overheat the base metal. And if you overheat the base metal, you can form an alloy of the steel and some of the content of the brass, I'm led to believe anyway, and that could cause intergranular cracking. More to the point, you can also very easily overheat the base metal and burn carbon out of it and damage the structure of the actual steel. With the TIG brazing, the process is very, very fast, and as long as you don't overheat the base metal, which is fairly easy not to do, then that doesn't happen. That doesn't happen at all. There is no overheating of the base metals as long as care is taken, and you shouldn't form any alloys of the steel and the copper. You have to remember that this is principally pure copper. It's almost pure copper we're working with here. It's not really a brass. People will refer to it as brazing. We refer to it as brazing. It's not brass. It's more than 90, I think it's around 98% copper with a very small amount of silicon, and that's it. People might refer to it as silicon bronze. It's basically copper silicon, and that's it. There's no other content in it. So it has that slight yellowy tinge, but it is almost pure copper. And no, as far as I'm aware, intergranular cracking is really not an issue with that as long as it's applied correctly. It's very strong. In terms of tensile strength, it's only a smidge lower. It's about 340 newtons a square mil. The steel's about, mild steel's typically 350-ish newtons a square mil. Obviously varies a little bit, but say 350 newtons a square mil. So you're there or thereabouts in terms of tensile to your mild steel. And it's very benign to apply. You know, it's relatively low temperature to apply. The adhesion's amazing to mild steel. It's a really good material to work with. Actually, it's a rod. I've said before, but I'll say it again for anybody that's not picked it up. The rod we use is a SIF product, an SIF product called Sil Copper 968, and it's used for a whole variety of things. And I'll tell you an area it's really, really useful for, which I use it for quite a lot, is mending cast iron. Obviously, we don't do much with cast iron here, but tools, broken tools and things, if they're made of cast iron, are a bit of a pain. Really quite tricky to sort out. Sil Copper, if you V out the joint so you can make a good braze deposit into the joint, you can repair those cast iron pieces with that Sil Copper 968 rod and a TIG welder, and the result is very, very strong, probably nearly as strong as the cast iron was originally, so really good for repairing cast iron. But anyway, yeah, that's where we're at on that. The next phase, that'll be out having a bit of dry build work done, and the other car will be undergoing what this one's just undergone, but we'll see that in a minute. In the meantime, we're going to wander over here, and I'm probably going to get some archive, but it's all right, I'm going to look the other way. Matt's working on the back. I'll explain what he's doing in just a sec. In the front, Stu has been working on a few things in the engine bay, one of which was checking the steering rack geometry and just making sure that the rack was at least reasonably appropriate to the new suspension setup, which it appears to be. I need to quiz Stu in a bit more detail, but from what he's deduced through some fairly rudimentary measurements, the rack length appears good for the wishbone lengths, and the design principle all appears good. So I think that was a thumbs up on that one. I don't think there's any inherent problems there. The next stage of what Stu's been working on was what he'd started last week, that we mentioned last week, which is the engine mounts. We were not at all happy with the engine mounts that had been fitted. They were far too rigid. They're a sort of an aftermarket American mount that would be used on a track day orientated car. They would be fine. Very good at constraining the motion of the engine, not very good at removing vibration from the engine. We don't want a lot of engine vibration in this car. It's a GT car. It's not a sports car. It's never going to go on a track. That's not the aim of this car at all. So to that end, we've done some revision on the engine mounts. Cal and I had a bit of a discussion on what we wanted to try and do, and we thought that maybe some hydraulically damped mounts might be a good idea. Cal came up with the brainwave of using of another car that was European, so relatively easy to source the bits for in Europe. That also used a pretty chunky V8, had similar power output, and that had readily available parts, and Mercedes engine mounts, Mercedes V8 engine mounts that were fitted to. They were fitted to pretty much every Mercedes that had a V8 in it, from the C63s to S-Class. They were fitted to a whole number of whole host of Mercedes use the same mount. So we're using, we've got a pair of those, the Febby Stein ones, and Stu's made the mountings onto the chassis rails to accept those, and then just this morning he's got the engine back in place on those mounts. I think the next phase of operations is going to be looking at the transmission mounting and continuing with a host of other paraphernalia in the front. The other thing that's going on is that we're trying to source from Heights the bushed alternative upper front arms to get rid of these spherical joints here, because we're not happy keeping these either. There'll be too much noise transmission there, so they've got to go. So we're working on resolving that. I also saw Cal wander through here, yes, with some alternative, some slightly lower pressure gas struts. So we're going to try those. I saw another comment about why don't you try XYZ gas struts? They're adjustable. We have used adjustable gas struts before. We couldn't get them, I believe we couldn't get them in the pressure range we actually need for this car, because the pressure is quite high on the tailgate on this, which is hence the error in first spec. Despite measuring the opening force, we've still got it slightly wrong. So we're on another pair, and we'll give those a go and see where we get with that. Additional to that, Tom's been working on the car. Tom's actually off today, but Tom's been working on that door, and he's pretty much there with the skin now for that. It's been a bit of a pain. There were a number of areas that weren't right on it. It was hollow in the middle, it had insufficient shape in the middle, it had insufficient shape at the top, is a little bit short, and the shape of the top wasn't quite right. So there's been quite a lot of rework going on that. However, I think he's pretty much, I'm looking around, well, I can't remember where he's actually left the skin, it's over there somewhere, but I think he's hopefully pretty much at the stage of that, actually fitting that to the frame. He's already had it on the frame to sort of line it up in the car and make sure everything kind of lines up, but then it's needed quite a lot more panel work to get it to be actually the right shape. So I think that's pretty much there. And then Matt is currently on with the tailgate, which is quite a big job. He's actually doing some weld build-up on the edges of the tailgate at the minute. He's been building it with the MIG round. Have you done any of that side yet? Yeah, okay, so I can't see it from here, but viewers will see it. He's been welding up the front corners of the tailgate because the shape is just not right. This tailgate surround, which we think is the original one for the car, is just a horrendous piece of metalwork. It's adrift from the right shape in almost every dimension. So Matt's been getting on pretty well with that. There's a few areas of it that are quite difficult to get right. This back edge, when you view the car downwards, obviously because of the angle of that, you actually see the flat section of the shut line along here. And because of that, this needs to be really accurate, otherwise your eye will be drawn to the inaccuracy of that. Now this has got to be leaded yet to get that exactly right, and as you can see it deviates slightly still at that end. It's a lot better than it was, but it still needs some more correction yet, but this is going to be leaded all along the back of this shut line to help correct that. And then both corners need a substantial chunk of lead putting in them, because the panel join line down here, the panel's pulled in and got a big flat spot basically through here. This is all far flatter than it should be, so that's got to have the curvature put back into it with lead around there, and that will then get this shut line correct around that corner by the time that's all faired in with lead, and the same that side. In the meantime, I say he's just building up with weld down the front edge of the tailgate this side, because the gaps vary dramatically from the corner to down here. Now the corner will be built out on the car with a bit of lead. At the back of the gutter, we've got to do some more lead work there, which will help close that gap up, but the gap varies wildly in that area, and it's just down to the tailgate. The width of the section on the tailgate varies, and I think they were ground to size or shaped, they were made to size when they were done originally, and I think they were just they ended up how they ended up. But anyway, it's needed building out. Matt's got that on there now, got the material dropped on with the MIG, and then he'll grind that back, trim that up and make that all right, and then he can start, once he's got the gap as fair as he can from the tailgate, then he'll start leading the car back to that and actually setting the exact gap. So yeah, it's quite a lot. There's a bit of work there that we haven't seen. To be fair, quite a lot of these areas on this car we haven't really seen, because this black e-coat hides everything incredibly well. And it's really hard to make a call about any of the lines on the car while they're covered in this black e-coat. It's almost impossible to tell how bad any of it is. When we clean that off and then see the metalwork as bright steel, then it immediately becomes obvious what needs addressing. But he's getting through it pretty well now. The gaps down this side of the car are absolutely superb now. So get the tailgate done, which is probably the most complicated piece on the car to gap. I'll say that, and then we'll get onto the bonnet. But I think the tailgate's a worse line because it's because of the compound angles all around it. It's probably the worst piece to try and get gapped correctly. And then other door in next week. We shouldn't be too far away from having a look at the bonnet at that point, but we are still waiting for the bonnet skin at the moment, so that's the hold up there. But that shouldn't be too far away. So that's where we're at on Interceptor. We'll march on and we'll go this way round. Now we'll go around the far side of the other Allegro, where Bobby's progressing with the final steps of the dry build work on this, which is chiefly revolving around the fuel lines, brake lines and AC lines. The brake lines he's pretty much got in place now. He's just sorting the brackets out for the front lines. He's got the rear line run, and he's got the routing all sorted at the rear for those lines. He's sorted the fuel line routing. As I mentioned last week, you've got the fuel filter housing in place, the fuel pressure regulator brackets in place. He's got a plan there for how the lines are being routed, and he's got the brackets welded on under the car, which are going to carry the fuel lines, because we're going to have hard lines under the centre section of the car, terminating at 2 bulkhead mountings at each end, and changing to flexible lines at the bulkhead mountings at the front and rear. So we run flexis into the engine bay, flexis up and across the top of the fuel tank to the fuel pump unit that's in the tank. That'll be an in-tank pump at the back. And then the same with the brake lines, running a hard line down the car, terminating front and rear, and changing to flexis at each end. Just keeps it neater under the car. So that's been going ahead. And then the other area was planning and starting to execute the AC lines. I think I'd mentioned probably in the last video about the end forming required on the AC lines, and the fact that we have struggled in the past, and I think I may have mentioned, if anybody knew, and I haven't seen a comment saying anybody had a great idea. Somebody had said about try Vivor or something. I mean, it's, yeah, the Chinese haven't made us a kit, unfortunately, so I'm not going to find anything there. I mean, been around the house a little bit. I think I mentioned last week a fairly local company to us that specialise in tube end forming and automotive plumbing solutions, and I drew up the tube ends we needed and sent the drawings to them, and no go, they don't have any tooling. So Bobby, the action man, has taken it on his own head, and if I just leave you there a minute, Jamie, and I'll wander over here and grab some bits off Bobby's toolbox. In fact, actually, if you come over here, Jamie, you'll be able to. I can show you on Bobby's box what Bobby's been up to. But Bobby's done his usual of well, I'll just make it then. So he's made a bit of a prototype tool which he lashed up in about an hour and a half yesterday evening after I'd gone, and did a bit of quick machining work. And did a few test runs, and he's now got the ability to put on, that's what we would call an AN, it's a number 6 end form, which is onto 3/8 inch diameter aluminium tubing, and he's making these end forms successfully. And so he's made a variety to varying quality standards, but using the sequence, using a sequence of these 2 plugs, which basically clamp the virgin tube, if you will, in the clamp blocks, tighten them up. That will be done a different way, I'll explain in a minute, and then use a sequence of these 2 ends. First one necks the end down to the new diameter, and then the second one crushes it in onto itself to form the lip, while supporting it in the bore. That's a little bit tight in that one to demonstrate, but basically that supports the bore and squeezes it in to make the neck, and that one initially tapers the end in to get you the right shape to start with. So yeah, there's been a bit of toing and froing to get everything set right, but he's got a plan together there now with some tooling. So now he's got that, Bobby's going to do, he likes his little side projects. So as a little side project, Bobby's going to draw up the tools properly, draw up the plugs properly. I think the plan, talking to him this morning, is he's going to arrange it all on a little linear rail, you know, a bearing, a strong but small linear bearing track. And then we're going to use probably an off-the-shelf, probably Chinese-made hydraulic swage tool as the power unit on the end of it. And we'll probably have a screwed single Acme threaded clamp to clamp the clamp blocks, and then we can make different clamp blocks that interchange on dowels onto that track with a screw thread that clamps them, and then these will also be on the same track on square blocks that drop onto the bearings, and basically make a tool that gives us the 3 different AC line swages. It's something we're going to put a few quid into to get right, because nobody we talk to can supply us with the end form tooling, and it's something we want to be able to do because we want to make our AC lines in aluminium hardline. We know we can buy them in pre-cut lengths. That doesn't work because none of the lengths are exactly right, and they need to be exactly right, and nobody can seem to supply us with an off-the-shelf end form tool. So at this point we're just going to make our own. We'll get these machined once Bobby's drawn up the clamp blocks and the swage tools. We'll get them machined in D2 tool steel, get them hardened. The pins will be inserts, these will screw in so that we can change them if they get broken. And then the housings, we'll get them all machined in D2 tool steel and just harden them, probably just harden them here because we can air harden them. And then we'll have a set of tools for making AC lines. So one of the million offshoots you get when you're trying to build a car is building the tools to build it, because nobody can supply them. It seems that nobody really makes proper hardline AC lines in the aftermarket to fit your car and has the appropriate end forming to do it. So we'll do it ourselves. So that's Bobby's other little bit of progress on that. And I think that pretty much sums up where we're at on the Allegro. I'll say hopefully next week this car will be completely stripped down on the rotisserie and being seam brazed, same as the other car was. And then we really are in need of the panels then, so hopefully we won't be too far away. That's where we're at on that. We'll walk past a pile of dismembered Integra stroke Allegro and into the body prep bay, where Mark's on what we discussed last week, the final sort of stages on the Churchill, primarily the engine bay prep, which, as we said, there's probably around a week's work in the engine bay, and probably looking like that wasn't far off, really, I would say, with how things are looking. Yeah, that's it, you've not been on it too long so far. So yeah, the engine bay's looking pretty good. There's a lot of detail sanding, it's fiddly areas, wobbly edges, generally lots of awkward bits to sand, really. There's not another way around it, really. Lots of just hand sanding work, reaching into corners and wearing out your fingertips. That's the bulk of the work there. It's all polyester coated. There's enough building there to sand everything back to get all the lumpy bumpy bits out from where the welds are and where the ripply edges are and where the spot welds are and all of the other million bits that make an engine bay look a bit untidy. It's just all got to be smoothed out and tidied up and made to look pleasing once it's got a glossy coat of paint on it. So that's progressing pretty well. I noticed Marty's also been picking up a few areas around the car, because earlier in the week, was that this week or tail end of last week, you had the trims on?
Well, last week.
Yeah, tail end of last week, just after, around when the video was done last week actually, but running into earlier this week. The brass trims have all been fitted to the car, so we've had the swage line trims on down the side, all the way from one end of the car to the other, and just adjusting on a couple of the holes. Some adjustments were needed. There were a couple that weren't quite in the right places, so a couple of those holes have been adjusted and altered. So those trim lines now run smooth all the way down the car. And we've worked out where we've got to trim the brass, which brass chrome. Some of them are already chromed, and we'll probably need we'll need dechroming, because the trim on this car is going to be copper. So some of them will need dechroming. Some are just raw brass at the moment. But a number of them need trimming to length and then end plugs making for them. The ends will be braze filled or little brass plugs made and silver soldered into the ends to cap off the ends of the trims, because a lot of them are just an open-ended sort of C-section, so they'll need capping off. Now the lengths can be determined accurately. Until the lead work and filler work was done, you can't actually determine the exact lengths of those side trims. Now we can. That can be done. And then, yeah, we're pretty much then about at epoxy stage, aren't we? Probably next week-ish, somewhere around there. There's bound to be something that trips us up, but hopefully, yeah, next week I should think we'll be into epoxy. And then in parallel with that, we've got Steve back down here at the moment, because he's waiting for he's waiting for a bit more wiring work upstairs. I think he'll be splitting his time a bit there, but there's some design work. He's caught up with the design work on that front, so he's back down doing some dusty work again for a bit now. And Gaz has got the bonding work done on Redux. So the quarter panels are bonded on, the complete roof and scuttle, which is all one piece as you'll have seen before, that's all bonded in place, and the rear section is bonded in place. He's then mocked up the doors, bonnet and boot, got to make sure everything's all still good there, and then got the rear roof section bonded in place, which has to be done obviously after the main roof section. Got the edges all prepared on that, and then got that bonded in place. And now he's on the initial prep, getting everything keyed up and ready for first coat of polyester high build going onto the panels on that. In the meantime, Steve in the foreground here is doing all the detail edge prep work on the doors, where the bond line was done around the doors. When these skins have been made, we've made these with a little stepped return so that they simulate the original steel outer skin. So we don't have the metal of the outer skin all the way to the edge of the door. We stop that metal short of the edge, and we actually wrap the carbon around and then the bond line is back here. So Steve's just tidying up where the bonding inevitably squeezes out around the edges. He's just tidying that back and sanding that back, so that when we have a complete carbon edge to the door, which gives us the ability to block sand that edge a little bit if we need to adjust anything. But it also means that the edge of the door has no chance of splitting occurring on the edge, which is a pet hate that we have come across with steel and carbon skin steel doors before. We've had issues with them splitting on the edges. So the target here was for the door to be carbon on the edge of the aperture all the way around, and the return to steel being done further back. So that's all worked well. And yeah, Steve's just doing all that detail, nitty gritty sanding around the edges. And I think at that point, that pretty much wraps up where we are this side. So on that, one other thing. We'll have a look at our new little router room and see, because there's a little bit more progress in there. There's another thing in there now as well. Now it's starting to look quite busy in there, so we'll go and have a quick glance at that. Put that down there. So yes, moving on from the fabrication shop, I'll quickly dwell in here before handing over to Cal, in that we have another bit of kit in here, which is the panel saw, which I picked up locally from a machine clearance, well, a warehouse clearance chat. I think it came out of a home base store somewhere, and it's pretty obvious that you need a way of cutting big boards into small pieces if you're going to make blocks to machine things from, and the panel saw seemed to me the best way of achieving cutting up full boards of MDF and tooling board into smaller pieces without taking up half the unit. Obviously you could use a table saw or a horizontal panel saw, but both of those need enormous amounts of space in order to operate, whereas a vertical panel saw is very space efficient. Lift the board, slide the tool along, lift the board on, do all your cutting with the board just sat on the saw, and it just keeps the space requirement right down. So much nicer way of doing it. So that's the plan with that. That's all up and running. It wants a few titillation. It needs some new buttons in it, but they're not very expensive, and it could do with the bottom step guide refacing, really recutting. I think that wants a little slice with the saw to recut that and tidy that up. But yeah, that's all looking pretty good. It's all up, running, working, and does what it should do. Needs a couple of adjustments, and I probably ought to get a new blade for it really as well, because that's looking a bit tired. But that's all good. Router's all up and running. Tool change is working. It's changing everything over. A little shout out to, because their service has been very good, APT in Glasgow, Associated Production Tools in Glasgow. Very helpful, very quick, and got all of the tools and tool holders to us in double quick time, so really good. Order one day, pretty much get the bits the next day. They're really good to deal with actually. And yeah, the big news on this one is tomorrow we are having a chat with Richard from Autodesk, who's going to talk us through and give us some helping hands on the cam side of operating this machine. We're also going to have a look at the cam for plasma cutter as well while he's here, because he wants to have a little look at the post processor on that and do some work on that. But the primary purpose of tomorrow is working on getting our Fusion 360 CAD models into G-code that this machine will run. We'll see how far down that line we get. I'm aware that there's plenty of things that could trip us up on that path, but hopefully we've got enough things in place that we're able to do that tomorrow. You'll find out next week. On that note, I'll hand over to Cal and let him take you around the assembly shop.
Right, let's go and see what's been going on. Hang on a sec, I'm just paranoid then my microphone wasn't turned on. We don't want to do the whole thing and then find there's no sound. Yeah. So I'm going to start quickly by mentioning the Project Norman E-Type. The reason I'm starting with that is because I seem to need a visual cue for everything I talk about, and I know I'll forget if I don't start with it because it's not in here. But we've been looking at the bodywork on the rear end. Well, we've actually been looking at two things. Luke's been carrying on with the interior design work. Did a little bit more refinement on the doors. we had the owner over here this week, so we'd done that kind of rough paper and card mock-up of the interior. So we had him over so he could sit in it, make sure he was happy with the layout of everything, have a look at the CAD actually on the screen so we could rotate it in front of him. And there were a few little pointers. He wanted the armrest slightly higher, the armrest lengthening forward a bit, so it was a bit closer to where the shifter's going to be, and that then allowed us to potentially put a cup holder inside the armrest and still have a usable cubby holder in there as well. The idea being that potentially we can slide the cup holder out. To be determined. He also decided he wanted the armrest to open sideways rather than backwards, so it was a bit of an easier motion to do, and there were a couple of other small details. But yes, I think on the whole, pretty happy, liking the overall design. We've done a few more little changes on the door card. We talked about running a little bit of chrome beading along the bottom of the dash that flows down into the console that kind of divides the piano black fascia from the leather that will surround it. We're mocking all this up with like a red leather just in the CAD because it shows the contrast nicely, although that's not necessarily the chosen colour. And in fact, we're getting to the point now where we really need to confirm the exterior colour, because although we're a long way from painting it, the exterior colour potentially dictates what the interior colour is going to be, and the interior colour might dictate the relative sizes of some of the parts on the doors, because it may be that we border the fascia panel with a black dash top, depending on what the exterior colour is. It may be that we don't, and depending on what that colour is, having a bigger or smaller area kind of decides how it looks proportionally. So lots going on there, but rear end was another area we were looking at. Now, we'd planned originally to do the whole back end as one carbon fibre piece. So we'd surface modelled the rear end to the level where we could actually machine a pattern of that, which would be a full-size representation of the rear end of the car machined in MDF. Then we would pull a fiberglass mould from that, and Chaos Composites would make the rear end in carbon fibre. However, there was a little change of plan which we mentioned previously. We were going to do this roll bar idea where a roll bar popped up from behind the sort of back of the cabin area. We were going to have a roof stretched over that, and it was very much going to be a temporary emergency use roof. However, the customer, after mulling it over for a while, decided to go back to actually having a fully functional usable soft top, which meant we almost had to go back to a standard soft top on there. At that point, the back of the bodywork at the back of the cockpit area was going back to almost standard. So the changes we've made on the quarters are essentially from the boot shut outboard all the way around, and the rear valet, well, sort of from the back of the boot lid all the way around the rear and underneath. But the area in front of the boot lid is standard, and the very front of the quarters is standard. And at that point, we started debating whether actually it might be better to do it all in steel. So we kind of did a cross-sectional analysis of it all to see where those changes were, and also to sort of illustrate to whoever's going to do the sheet metal what areas and what shapes we're going to need to do. As it is, I think we're now going to do it in metal, and that actually ties in with Nat's new CNC router quite nicely, because if we're doing it in the steel, we'll create what they call an egg box book, so a kind of interlocked two-dimensional profiles to create the shape, potentially with some solid sections around the arches and any other hard lines on there. But because we've already got all of the shapes modelled in CAD, it's going to be quite easy for us to profile that and then CNC the profiles potentially on the CNC router. So if that goes to plan, hopefully we'll be able to do that in-house. So that's E-Type. Escorts. So on Saturday, Dean popped over and dropped off all of the things that he's just leathered. So they were the main parcel shelf, bulkhead panel, fuel tank cover panel, the floor panels in the rear seat area, and I think the centre console and the front speaker surrounds. And that's now opened up quite a lot of possibilities in terms of the upholstery. Gibbo's carrying on with the boot carpeting, so I think he was just finishing off the interior carpet last week, moved on to doing all the carpet sections in the boot, which are about done now. Dean's taken the front carpets to now edge whip those, so we'll get them back fairly soon in a finished state so we can get them in the car. And then one of the final pieces of upholstery is going to be the cage. And we are going to leather the cage. Now that's going to be a case of hand stitching it in the same way you would a steering wheel. So what we'll have is a rectangular strip of leather, if you like, long rectangle that will wrap around the cage. It'll be sized to exactly go around and meet edge to edge on the side, as you would with a steering wheel. And then before fitting it, Dean will run a stitch line down the very edge one side of it and the very edge the other side of it. So when it's wrapped around and butted up, those two seams are sort of next to each other, but with a gap between them. And then he'll hand stitch between the loops of the seam all the way down, basically pulling the edges together. So that's the plan with the cage. Now we were looking at it and trying to work out the neatest way to do the corners and the intersections. Obviously on the corner where the tube is longer on the outside edge than the inside edge, it's likely you'll end up with some puckering on the inside. As you often tend to see a little bit on steering wheels, you'll often see that it's slightly puckered up on the inside. So we were trying to think of a way of doing that would be neater, and I came up with the idea of actually making some 3D printed cappings that are two-piece that go around the intersections and extend, you know, an inch or two down each leg of the cage, that we could potentially then upholster separately. We'll just do straight sections that end before the joints and then upholster these 3D printed cappings and put them over and bond them on afterwards, so they kind of form a nicely upholstered section just over those intersections. So Luke's been in there, he's 3D scanned all the cage intersections, he's now modelled the parts. We did a quick 3D print of one of them, done a couple of changes because I wasn't quite happy with the fit, but looking pretty good now. I think the method's going to work, so watch this space on that one. It's not something we've done before, it was just an idea that came to me to finish the cage neatly. So that's looking good. The interior panels all look great. I couldn't help but assemble some bits. So one of the door panels, I've put the speaker grill on it with the little bronze anodised badge and the leathered surround on it. And it's looking so good. So it's at that point where I just desperately want to see it all go together. We're just waiting for some door handle components back from Xylan, and that literally is the last bit to then get the doors together. So that's an exciting prospect. And then on that subject, with the interior starting to take shape, I've done the headlining on that car. I've just got to do the clips in the little trim rail that goes up the C-pillar. They're a bit of a strange design on the Mark 1 for a suspended headlining. Normally, there's a bit of a knack to suspended headlinings, but they're not, you know, once you've done a few, you get pretty good at them. And usually they tuck into the apertures, the window apertures, all the way around. So you'll start by putting the rods through, clipping them in place, tensioning it front and back and clipping it with bulldog clips along the front and rear screen apertures. A lot of shuffling and wiggling and tensioning and getting it all pulled into the right place. Normally then bulldog clip down the door aperture and the rear window aperture, both sides, bit more tensioning, make sure you're happy all the creases are out, and then you kind of remove a section of bulldog clips, glue it, clip it back and carry on going around until it's all glued, and then trim off the excess. On the Escort, it tucks into the door aperture and the screen aperture and the rear window aperture, but on the rear side windows there's a channel section running up the C-pillar and over the top of that window, and the headlining tucks into that, so the rear window doesn't actually overlap the headlining, and there's a section of exposed painted metal above the rear window, and then there's a slightly odd bit just at the top corner of the door where the channel ends and then it transitions to being tucked into the door, and then you have to have like a diagonal cut straight across the headlining on there. And that is the bit that makes it tricky on the Escorts, is that tucking process. It's not too bad on a vinyl headlining like we did on Gordon's car, but this is Alcantara, and there is next to no stretch in Alcantara, which makes it a lot harder to get all the creases out. So it was one of the more challenging ones I've done. And then the final challenge is when you're tucking it into that channel, the tendency is for the clip to pull on more tension than you had in certain areas, wherever you put the clip, and then it pulls more creases into it. So it's not an easy job, that one, but we're about there. And then that'll allow the windscreen to go in, rear window to go in. We're going to leave the side windows out at the minute because it's going to be easier to upholster the cage with those out. But with those windows in, we can get the windscreen wipers on. We can pretty much crack on and get the rest of the dash together now. So yeah, it's definitely getting into that exciting bit. Rear lights as well, you'll see there's one in at the minute. We finally got everything together on those with the anodising that came back, the black bezels. So that's all new parts now, billet inner, billet outer bezel, new lenses from MST, and the new gaskets from MST. I've actually noticed that since we made those, they've now launched their own remade inner. I'm not sure what the construction method is on it, but it's very similar in that they've done like twist-in bulb holder orifices, if that's a word. Yeah, it is. to hold the bulbs on it, which is very similar to what we've done. So yeah, that's looking good. Kuma, no, tell you what, not Kuma. More on project one. Wiring, if you perhaps go around that side. Alex has been, as is evidenced by this pile of rope here, Alex has been looking at the engine wiring. So one of the things we got back from anodizing was the cam cover. There's two sections to it now. The lower section is quite similar to the original, but with mounting bosses on it. It's got mounts for the coil packs, and it's got, critically, various little threaded sections on it to attach P-clips to. And then there's an outer cover that goes on that, and the idea is we've got a nice place to route our wiring through inside there. So the wiring to the coolant temperature sensor, the alternator, and the oil pressure and temp. We've got a combined oil pressure and temp sensor that's in the filter housing. That will all be routed through here along with the wires to the coil packs. Hence you can see Alex has started to lay this out in rope so he can then get his lengths for the final loom. Then there's going to be another branch back here which will come along to the injectors, and then we've got two throttle position sensors. So one is actually on the throttle bodies, which gives an actual throttle position, and then the other one's on the throttle motor. It's a fly-by-wire setup to give the motor position, and generally speaking those two should tally up, but having sensors on both does give you a sort of fault warning if one goes out of kilter to the other. And then we've got a cam sensor going down there, which we've actually just sent off the drawings for a housing we've designed, which mounts a cam sensor onto the the dry sump pump. There's a tacho drive on there, which is like just a little slot in the end of the shaft in that, and that gives us a half a turn for every crank rotation, or two, I can't remember off the top of my head now, which basically gives you cam position information. It just gives you a couple of benefits. It means that the engine can be run non-wasted spark because it knows which cycle it's on. Normally, if you've just got one gap on the crank trigger, it knows what position the crank's in, but of course it doesn't know that cylinder 1, for instance, it doesn't know whether that's on its compression stroke or on its exhaust stroke. So basically, wasted spark, it doesn't know the position, so it sparks both on the ignition stroke and on the exhaust stroke, but that spark is wasted, hence the name. It doesn't do anything, it just sparks and then there's no mixture to burn. With the cam phase sensor, it also knows what position of the cycle each piston is on, essentially. So it will do sequential ignition, so it only sparks the cylinder it's going to spark, and also sequential injection, so rather than doing two pulses, which is how it works when you're doing a wasted spark setup where the engine doesn't know what position each piston's in, it does one pulse of fuel into the intake when the valve is shut, and then another on the intake stroke to add the second half of the appropriate amount of fuel. With fully sequential, which you need a cam sensor for, it injects only at the right on the intake stroke and sparks only on the ignition stroke. But there are other benefits. With the Motec, we've got knock sensing. Because it knows what each cylinder is doing, it knows that when it detects the knock, it knows which cylinder the knock is coming from, rather than just that there is knock, which is a useful addition as well. So, and it also synchronises the engine up slightly quicker when you're first cranking it. So it's useful to have fully sequential. Long way of saying we've got a cam sensor in there. And I think there's one more thing down on that leg of the loom down there. Yes, the throttle motor connection itself. So with all of that measured up, Alex is going to take that back out of there. He's already done the sort of theoretical design for the loom. That's all on the system. I don't know if I've mentioned before, actually, he's using Rapid Harness. It's the software package that we're using to do all the harness design, which then generates kind of data sheets for everything, wiring schematics for everything. So the last piece of information is just all these lengths which he'll put on and then be able to start making the engine harness, and it'll be the same for both cars, so we can knock out both of those. And that is the wiring complete. So we are pretty much on the countdown with these now. You'll notice there's some tape on these reservoirs because I've just sent the caps away to be laser etched as well, along with a couple of the interior bits. So the gear shifter surround has the information that the switches do laser etched into it, and the gear pattern And then there's another bit in there. Oh, the handbrake surround's got a logo engraved into it, the Project 1 or Project Kuma, and then these caps will have engraved into them what fluid is in that reservoir. Okay, right, moving on over here. Camaro. Anthony's been on with the Dino Liner. So that's the sound deadening / heat deadening that we put over the top of the normal Dynamat in the areas that are sort of really susceptible to noise and heat transmission. So generally floor pans over the transmission tunnel. It's the 1/2 inch thick stuff on that. So that's all gone in, and then sort of creeping forwards with interior bits. The seat belts, he's just been trial fitting the seat belts in there. They're kind of just the original GM. I think they're actually lap belts. So interestingly, they've got like an inertia reel socket on them. It's a very short inertia reel, just pulls out a little bit, but it's quite cool actually. And then the front speakers. So Luke's finished his design for the bezel around the speaker grille, which will go on to, if not the original kick panel, certainly a flat representation of it. And then Anthony's been on with mounting the speakers himself, so we've got 6.5 inch round focal coax 2-ways, which are going in the kick panels. So he's been making up basically an adapter plate to go in where the original air vent feed into the footwell is and mount those speakers down there. So they'll be mounted to the shell, and then kick panel will go over with our new grille design on it. So that's all taking shape. It's pretty much just at the stage of kind of ticking through sort of remaining assembly jobs on that until we've got the rest of the interior here. And then the only major thing really is the wiring on that, which we've not been able to start on yet, but still looking good. And Project Kuma, I obviously talked about the fact we're doing the engine loom, and that'll be made, the design works the same for both cars, so this one will be made in tandem with that one. And Luke has been on just 3D scanning. Now we've got the interior panels all back for that car. We're happy with the layout of everything. We're going to make up the panels for this. We only made one set to start with until we were happy that it was all going to work and sit into place and look how we wanted it to look, which it does. But we're aware that there might be, although the two cars were built in tandem, it's likely there's going to be some millimetre differences here and there on these panels and the cage, etc. So he's just 3D scanned the inside of this, so we can basically put the CAD models of all the panels we made for that car into this one, see how they sit, and make any edits to the panels before they get cut. Door panels I think will be the same, although I bet the holes will be in different positions, because we noticed even on Project 1, one door, the sort of attachment clip holes were different on one side to the other. Only subtly, but a couple of them were a good sort of 8mm difference on one car to the other. And this, I think that one's got complete replacement door shells on, whereas this one's original frames with a new skin. So it's likely they'll be slightly different to that car. So yeah, we're just checking all of that, and then we can laser cut the door cards and rear quarter cards, which are done in ABS, and then we did the parcel shelf, bulkhead panel and boot and rear floor area panels in aluminium. So yeah, I'm looking forward to getting the interior together on this one as well. And that, I think, is about it. I did have a scan through and look, see if there's any questions from last week, but there wasn't really anything. So if you do have any questions, feel free to comment, and we shall attempt to answer them next week. And I won't see you next week, because I'm away next week, but Nat will no doubt do the honours, and I shall see you in a couple of weeks. Okie dokie, that should work.